what are the different classes of IPv4 addresses and give the range of each class. IPv4 addressing scheme. How many classes are there that we have to answer, and the range of each class. So before we go ahead, there are two schemes, IPv4 addressing scheme and IPv6 addressing scheme. IPv4 is a 32-bit addressing scheme. This is dotted decimal, that is we have 4 numbers from 0 to 255 separated by a dot. Now this IP addressing scheme is divided into 5 classes. Now we have private addresses, public addresses, loopback addresses, some special addresses, which addresses to be used by the public network, internet network, how many hosts can be there, how many networks can be there. All these are answered by the scheme being devised, and that is called the IPv4 addressing scheme, and divided into 5 different classes so that we understand what class belongs to what or does what. In IPv6, because it is elevating now, IPv6 is a 128-bit addressing scheme. Because the 32-bit IPv4 can only handle up to approximately 4 billion devices. And many of these IPv4 addresses, they are not being used or they are just wasted. And we have around 7 to 8 billion people right now. Everyone is having different gadgets. So in order to cater them, IPv6 has come. But since IPv4 is still there, so we need to understand that what is the addressing scheme? What are the classes? So we have 5 classes, A, B, C, D, E. There are 5 classes. Now these classes are dependent, or they have evolved only through the first octet. Now let us take an example. We have a number 192.168.1.152. This is a proper IPv4 address. Now this is a class C address. Now after we complete the discussion, you will realize why it is class C address or why it falls in the class C. So because this is dotted decimal, so there are 3 dots and there are 4 numbers, or 4 numbers as I indicated, from 0 to 255. Now we start from first octet. This first octet, there is a decimal number, or when we convert it into binary, there will be a proper form. So if we start from the left, the first octet, all the 5 classes from A to E, they are identified by the first octet, that is the 8 bits on the leftmost, or you can call that the first decimal number on the leftmost when we start from left. So the first octet leftmost of IP address, the classes are identified by this number. Alright? Which bit is fixed, that decides that which class are we talking about. This class A to E, please understand, all depends on the first octet. Now all the IP address, for example, we have the IPv4 32-bit address. So this address, assume that you are sitting somewhere. You are a host. There will be some other person in your network. He is also a host. And you are in a network, there may be multiple hosts. So first is to identify that on which network you are, because there are millions of networks around. In internet is called as networks of networks. So which network are you belonging? And when you understand in which network you are, what host you are, that is which system, because IP is all about uniquely identifying a host. So the number of networks and hosts per class can be defined. There is a formula, proper formula. If we understand how many network bits are there and how many host bits are there. For example, if the first bit is reserved, that is 0, it is always reserved, it is class A. Second, class B, if the first 2 bits of the first octet is 10. Okay. So this is how you decide in which network you are. That is 2 to the power number of network bits. Because the 32-bit address has network bits also and host bit also. The left, it is decided by the class, what are the number of network bits, and the remaining are called the host bit. So these all people or the gadgets inside a network can be found out, and the host, how many hosts can be in a network, can also be found out. So for example, class C 110 is fixed as the first 3 numbers of the leftmost bit. Please remember, when we calculate the host IP address, 2 IP addresses are decreased because they cannot be assigned to host. Because the first IP of the network is the network number, that is in which network you are belonging, and the last IP is nothing but for the broadcast IP, that is if you want to send a message or send some packet, it will go to everyone in the network. So always you will see the number of hosts will always be 2 less than twice to the power of host bit. So all these class A to E, it all depends on the first octet. What are the bits being specified? They cannot change. For example, class E 1111, the leftmost octet. In IPv4, this is the Internet Protocol version 4. We have 5 classes: class A, class B, class C, class D, class E. Now this first class A address, because IPv4 has an addressing scheme. Because this is a 32-bit address, all depends on the 4 octets. 32 bits, that means we have 32 1 and zeros, but they are separated by dots. So we have this 8-bit, then 8-bit, then 8-bit, then 8-bit, and they are separated by dots. This 8 into 4 becomes 32. So if you take the first 8-bit, or you can say that from the left if we start, if the first bit of this 8-bit chunk, that is the group, the first bit, if it is fixed as 0, if the first bit of this whole IPv4 address is fixed as 0, then these numbers being formed are called as class A address. They will fall in class A address. For example, the first number will be 00000001 because 0 is fixed. What is the decimal value of this? 1. What is the highest? 0 is fixed. So the highest can be 1, 1, all ones then. This is the highest one. What is the decimal value of this bit formation? 127. So 1 to 127, if the first, in the IPv4, the first number, that is the decimal dotted number, the first number, if it is between 1 to 127, then you can safely say that this address is belonging to class A address. Once this 0 is fixed, the other 7 bits, these are network address. Because every IP is having a network address also and host address also. So the bit which we have fixed, there are 7 bits remaining. These 7 bits are network address. Already? Now, once this 8-bit one is fixed, 7 bits are for network address. How many bits are remaining? 32. 8 we have already done. So the remaining are 24 bits. These 24 bits are for the host address. Please remember the IP is uniquely identifying your system on a network or on in the universe actually. So how many networks can be formed or how many networks it can cater? 2 to the power 7. The formula can be seen here. And how many hosts per network? That is, these many networks can be there and these many people, these many gadgets can be there inside one network. So it can be 2 to the power 24. This is from network. From here to here, it is for the host per network. 2 to the power 24. This is class A address. Okay. What is the range then? As I indicated earlier, the minimum can be 00000 and 127. The highest can be 255, 255, 255 because each octet can have a maximum of 2 to the power 8 minus 1. That is 2 to the power 8 is 256. So it comes down to minus 1. So 255 can be higher because we start from 0. So this octet 1 to 127. So the first one I am showing 0 is fixed. All NNNN are the network bits and HHH are the host bits. But if I say you 1 to 126 only we can use. You'll say you just said that it can go from 1 to 127. Why it is 126? Why you are not taking 127 also? The answer is this 127 is reserved for loopback IP address. That is normally if you go to your browser and type 127.0.0.1, that is this is the range. The range is from 127.0.0.0 to 127.255 to 55 to 255. But these all are wasted. Only one is used. And that is for your loopback address. Whenever you ping or on browser you put, that is actually you are testing your network interface card. Okay. So your packet is not leaving your computer or your system. It is coming back. It is looping back just in order to see if the TCP IP is correct or your NIC card is is perfectly fine or not, properly connected or not. Alright, so this is 127 is used only for loopback addresses. That is why only class A can go from 1 to 126, the first octet. So the address class A or any address is having a network address and host address. Now how are you going to find out which one is the network address and which one is the host address? The default subnet mask or the subnet mask is used to identify which is the network bits and which are the host bit. For example, if you add this number with 255.0.0.0, 255 is all ones. So that will come out, the first octet will come out as it is, and that as it is actually the network address. That is how many networks we can have. If you have a very large network, this class A address is used, for example, for big organization. An example for class A address can be, let us have 10.50.120.7. Now, how will you say that this is a class A address? Why it is class A address? The answer is, we have to see the first octet. The first octet should belong from 1 to 127. Actually not 127, it should be 1 to 126. 127 is used for the loopback. So the first octet we are talking about, it can range from 1 to 126, as I said. Alright? So just see the first octet. This 10, when you see, oh, it is between 1 to 127. So this is a class A address. 127 we don't assign, as I just indicated earlier. We just see from 1 to 126. The first octet is 10, so it is belonging to class A address. And the other part, which is 10.120.7, is what? It is a host address. So there can be multiple network that is decided by 10, and 50.1.120.7 is deciding what is the host, what is the computer, what is the tablet inside that particular network. So if you have two devices or multiple devices, if they are on the same network, the first number of the IP address starting from the left or the leftmost bit combination, which is whatever combination decimal it becomes, it has to be between 1 to 126. So if I write a number 10.47.8.4, the first number is 10, the second of the both IPs. That means these two IPs are of the host of the same network, similar network. Don't worry about the next three octets. If I write 11.5.4.3, if we see the first octet, first decimal number, one is 10, one is 11. So this 11.5.4.3 is not belonging to the same network as 10.50.120.7. Okay. So if 10.1 is this in this network, 11 will be in some other network. In IPv4, the class B address, actually we have class A, B, C, D, E, 5 addresses. That is the addressing scheme is divided like that. So this IPv4 is a 32-bit address, and when we write it as dotted decimal. That is the first 8-bit, then 8, then 8, then 8, and they are dotted, means separated by dot. So in class B address, the first 2 bits of the leftmost octet is a combination of 8-bit, is fixed to 10. Class B, the first 2 bit fixed as 10. So the first bit, if they are decided that it will be 10, this is fixed. So what all are remaining? The remaining of them, that is the next 14 bits. So 2 is 2 in 8. There are, if you deduct 8 minus 2, it will be 6. And another octet, which is 8. 6 plus 8 is 14 bits. From here to here, these are the next 14 bits, and these are the network address. Please remember, there can be millions of network. So first we have to find the network, and then we have to find out the actual computer or a system inside that network, that is called the host. So these 14 bits are the network address in the class B address, and from here to here, these are the 16 bits. These are indicating the host address. So what is the range of IP address? When you fix 10 of an 8-bit address, so this is the first octet, leftmost octet. So 10 is fixed. What can be minimum? 00. 0000, this can be minimum. What can be maximum? All 10 you cannot change. So 111111. And when you convert this into decimal, it will be 128, the minimum one, and the maximum will be 191. The others, after that, there are 3 octets more, so it will be 0.0.0.0, and then with number 91, it will be 0.255.255.255. So it is from 128 to 191. And since we have 14 bits for network address, how many networks can be formed using the class B address? It is 2 to the power 14. This is how it is computed, number of networks. And how many computer or system or tablet or the computing devices can be put in one network? It can be 2 to the power 16. And you know that the first and the last we cannot use. So it will be 2 to the power 16 minus 2. These are the host address it can be in class B address. The default subnet mask of class B. First of all, what is subnet mask? This subnet mask is used to separate the network address and the host address, because the 32-bit address is consisting of these two. So when you apply this default subnet mask, actually you AND it with the actual address being given. This 255 is basically 11111111. So when you AND this, you get the network address out of it from the IP address, right? So this default subnet mask, this is default, there can be many, but this is the default subnet mask of class B. So this class of IP address, where it is employed? It is employed for a medium network like the MNC companies, multinational companies. It is not very big, it is not very small, medium one. So we have an example here, 172.16.55.13. Now you tell me which address does it belong, which class? And this is very clear because we are discussing class B, so it is class B address. But how it is? See, the first octet, when it is from 128 to 191, this is the category of class B address. 172 is the first octet. Does it belong between 128 and 191? Yes, absolutely. That is why this is a class B address. Alright. So what are these octets or the numbers which represent the network? The first two. Remember, the default subnet mask is 255.255.x.x. So the 172.16. So this 10 is fixed. 14 bits are the network bits. So this 172.16 is the number, or you can say the representation for the network. So we AND it with 255.255.x.x. That is, these two we get for the network. That is how subnet mask work with an IP to take out the network address. So 172.16 is the network it is representing. What is the remaining part? 55 and 30, that is dot 55 and dot 30. These are the remainder part which is actually representing a host. So first you have to find out the network, then the computing device inside that network, which is called the host. So 172.16.0.0, this is representing that this is a network. Okay. And then inside that we will have 172.16 dot say 1.1, that can be, or that can be given to the devices. So the device, let me just clear it to tell you that we have a number. Somebody comes up with a number 172.16.254.3. Now the devices with these two IP addresses, are they in the same network? Yes, you just have to check the first two octets. These first two octets, if there are 172.16, they are matching. You can easily say that these are on the same network. Let me write one more number, 172.55.54.74. Now you just have to match first two of it, 172 and 160. If they are not matching, that means the first one and the last one, which I've just written, they are not in the same network. All the three addresses are class B address. First two belong to one network. The third one belongs to another network. Okay, these two are in one network. The third one belongs to another network. All are class B address. In IPv4 addressing, we have class C address. IPv4 is a 32-bit address, and we have class A, class B, class C, class D, class E. 5. So there are special addresses, there are private, public, there are so many, loopback, etc. So in order to define which IP address range can be used by whom, these classes are being devised. So this is how 32-bit address is being formed. We have dotted decimal form. Okay, they are separated by the decimal values separated by dots. So when we start from the left, the first octet, that is the combination of 8-bit, in a class IP addressing scheme or class, the first 3-bit from the left is fixed to 110. They are already always fixed. Okay. So this is 110, 110. Here also you see 110. So these are fixed. So from here it is now very clear that when you fix 110, the next, you have to take all the 3 octets now. So what is the minimum of the first octet? 110. Then you just put all zeros. This is the minimum. And what is the maximum? 110 is fixed. You cannot change that. Now you can put all the ones here. Maximum can be 1. And what are the value of these, means decimal value of this binary? 192, and this one is 223. So the minimum first octet number for class C is 192, and the last one can be 223. The first, if the IP address, the first octet is between 192 and 223 inclusive, then we can say this is class C address. So this 110 is fixed. Now the upcoming 21 bits, that is you have to take all the 3 octets. You have the first 3 octets. How many are there? 8, 6, 24. 3 are fixed. So 24 minus 3. So 21 bits are remaining. So these 21 bits after 110, they are corresponding, or they are actually indicating the network address, and that can be computed using the subnet mask. Now these are 21 bits that are corresponding or indicating the network address, and the next 8 bit here, the last octet, you can say this is the host address. So you can have multiple networks that is given by 21 bits, and then inside that what computing device you have, that is the host address. So I already told you the class C IP address range from where 192.0.0.x, because x can be the host, will be the host, to 223.255.255.x, x will be the host. So the range of IP address, the first block will be what? 192.0.0.0. What can be maximum? Now you can just change the host. So it will be 192.0.0.255. Here 255. And what will be the last block? Same thing. You have 223. The highest can be, because you just have to worry about these 3 first octets. So 223.255.255.0. And you just have to, you can only change this host in order to get the host. So 223.255.255.255 will be the last block, highest number. So as I said, there will be a subnet mask in order to carry out the computation for the network address. The subnet mask will be this first 3 octet 255, 255, 255. That is how you can compute and find out the network address, because every IP address is divided into a network address and the host address. So the network address can be computed by subnet mask, which is ANDed with the actual IP to get the network address. ANDing is done. So what are the ranges, or we can say how many addresses are possible, since we have 21 bits for the network address 2 to the power 21, and the host, there are only 8 bits, so 2 to the power 8, but the first and last you cannot assign. First is for the network, second is, the last one is for the broadcast IP. So the maximum host in a network can only be 254. So the size is limited. Number of hosts can be limited in a network. So where do we actually employ this class C address? For a small network, for example, a company or a college, even for a school, this can be assigned, because it is quite limited here. Class C addresses, number of hosts in one network can only be maximum 254. Okay. So that is how this class C address is used. Normally you will see 192.168. like that in your computer. So if we take an example, 192.168.178.1, how do we know that which class does this address belong? Whenever we learn in a college or in our theory, you will always see 192.168.1.1. This kind of initially, people give this in their computer using those network settings and adapter changing, etc. So how do you know that this is a class C address? Because class C address, the first octet starts from 192, ends with 223, both are inclusive. So do this 192 belong to 192 and 223? Yes, it is there. 192 is already there, the first octet. So it is the C address, because the first octet defines which class it is. So the first, second and third, these three octets, they are corresponding to, or they are representing the network. They are representing what? The network. Which network we are talking about, or which you can say subnet you are talking about. And this dot 1 or 1 is actually the IP, or not the IP, basically it is representing the host, because network address and host address combined is called the IP. How do we know that certain device is on the same network or not? If I write 192.168.178 say 5. So the first three octets, 192, 168, 178 and 5, these three, all these three are belonging to the same network, because the first three octets, they are matching. But the other network, if I say 192.168.179.5, so just have to match the first three octet. So this is matching, but this is not matching. 179 is not equal to 178. So all these three addresses which I told you, they are class C addresses, but the first two addresses belong to the same network, but the third one is not belonging to the same network. Class D address in IPv4 Internet Protocol version 4, we have 5 classes: class A, class B, class C, class D, class E. So the first octet is going to define which class you are in. So the IP address of IPv4 is written in dotted decimal form. So there will be a decimal number, 4 decimal number, and they are separated by dots. So how do we know that this is a class D address? So the first 4 bit from the leftmost, if we start, the 4 bit of the first octet will be fixed to 1110. So the very first 4 bits of the first octet will be fixed, or is fixed as 110. So what is the minimum? Put more zeros here, and this 1110 is fixed. So now you can have ones. All ones are the maximum. So the decimal value of this first one is 224. The last one is 239. So that means the class D has the IP address range from where? From 224 till 239. Minimum can be 224.0.0.0. Maximum can be 239.255.255.255. This is minimum, maximum. Now you will ask for the subnet mask, because we already seen A, B, C has subnet mask. But class D does not have any subnet mask. What is the special reason about that? We don't have any subnet mask for class D. Okay? Because class A has 255.x.x.x. Then we have class B 255.254.x.x. Like that. We'll just talk about this example, but why we don't have class D subnet mask? Because class D is actually reserved for multicasting. So we have a group address, not a single address of a host. We have a multicast group address. That is, the packet or the datagram is not directed to only one host, but it is directed to multiple hosts, many hosts at the same time. Right? So when you don't want to get to a single host, you have a multitude of recipients, then we don't need a subnet mask. Because basically this subnet mask is finding the network address out of the IP. That is the whole work of subnet mask. So in multicasting, data is not destined to particular host. That is why there is no need, there is no requirement to actually find out or extract the host address from the IP address. That is why we don't require any subnet mask. So now we have the range as 224 to 239. Now let us come to an example. So we are given 227.21.6.173. You just have to check for the first octet. 227 is belonging to 224 and 239 or not. Yes, 227 is in the range of 224 to 239. So you just don't have to worry about other octets. It is a class D IP address. Class E IP address. In IPv4 IP version 4, we know that this scheme has class A to class E 5 range, you can say, classes, you can say. Okay. So these are the 4 octets, and these 4 octets are represented in decimal, and these decimal are having dots in between. So that is how it is called as dotted decimal form. The IPv4 scheme is like that. So how do you say that this is a class E address? The first 4 bit of the leftmost octet always is fixed as 1111. Okay, this is fixed. So what are the remaining? Because the address always begins with 1111, this is fixed. So when you fix this 1111, what is the minimum one? 11110000. Then 1111 is fixed. So maximum can be 1111. So you cannot change this first 4 bit, this is fixed. So what is the decimal value of this binary value? If you convert this, the first one will be 240 and the last one can be 255. Alright. So the IP is ranging like that. So the first octet, if it is between 240 and 255, you can safely say this is a class E address. As we discussed in class D, because class D is all about multicasting, so there will be a multicasting group address. Every IP address consists of a network address and a host address. So the subnet mask work is to take out or find out the network address. But as in class D, we don't need any network address because it is multicasting. Similarly, in class C, this is reserved for future use for the R&D purpose. That is why we don't need a subnet mask. Okay. So that is why this class E, like class D, is not having any subnet mask. The range is from 240 to 255, the first octet. So this is an example of class E. Don't worry about 164, 89, 28. If it is starting from 243, it is quite clear that it is between 240 and 255. This is a class E address.